Hello everyone. So today we are going to start the chapter of matrices, or we can say linear algebra, and topic name is Gauss Jordan method. Basically Gauss Jordan method is used to find inverse of any matrix. Okay, so to find A inverse. So what we do in this matrix, let us suppose what we have given A, we take it equivalent to identity matrix into A. Okay, now after this we apply elementary row operations. Now applying elementary row operation, what we get, we reduce this matrix A into an identity matrix, and this identity matrix into a new matrix B. This will remain as it is, this one. Okay, now what is this B? This B is itself the matrix A inverse. Why so? Because we have used the property of A inverse into A. This is A inverse into A, that is equal to what? Identity matrix, because this is a well-defined property. So this is the method which we are going to use in Gauss Jordan method. So let us take an example for this one. So question is, find A inverse using Gauss Jordan method and they have given us the matrix A is equal to 1 1 3 1 3 minus 3, then minus of 2 minus 4, then minus of 4. Okay, now this is the given matrix. So first of all, if we see at the matrix, so it is a 3 by 3 matrix. Okay, so let we know that A is equal to identity into A. Now this A matrix is given as 1 1 3 1 3 minus 3 minus 2 minus 4 and minus 4 is equal to the new matrix identity 1 0 0 0 1 0 0 0 1. It is of the same order as of the given matrix. If it is A is 3 by 3, so it will be 3 by 3, and whatever be the order of rank A, or matrix A, the same will be of the identity matrix. Okay, now I have to convert this matrix A in identity. That means all the diagonal elements should be 1 and rest of all elements should be 0. And the best part to do this type of question is to reduce this element to 1. Now in this given matrix it is already 1, so it will be best for us. Okay, so in very first step what we do, we reduce these two elements to 0. So that means I am operating on R2, that is R2 minus what? Now how can I make this 1 as 0? So if I take this 1 minus of this one 0, so that means R2 minus of R1 as 0. And on R3, what we are having, on R3 we have minus 2. So by using R1, if I take this minus 2 minus of, or we can say plus of 2 times R1, so that will make 0. So what we do, 2 times of R1. Okay, so matrix reduces to, this will be 1 1 3. Now on R2 minus of R1, so 1 minus 1 0. Now this 3 minus of 1 2 minus 3, and then minus of 3 minus 6. Now we have minus 2 plus 2 ones are 2 0, minus 4 plus 2, that is minus 2, minus 4 plus 3 2s are 6. Okay, what we are having, minus 4, and what we have, plus 2 times R1 is 3, so minus 4 plus 6. So what is the result? That is positive 2 is equilibrium to 1 0 and 0. Then we have R2 minus of R1, 0 minus 1 minus 1, this will be 1, this will be 0. Then R3 plus 2 times R1, 0 plus 2, that will be 2 0 and 1 in the matrix A. Okay, now next step is to reduce this minus 2 as 0. Okay, so what I do, now apply R3 tends to R3 plus R2. Okay, so what we get now? So in this equation 1, 1 and 3 will remain as it is. R3 plus R2. So R2 will remain as it is 0, 2 and minus 6. Or R3 0 plus 0, that will be 0. Minus 2 plus 2, it will be 0. 2 minus of 6, so it will be minus 4. Similar to the matrix. Now 1, 0 and 0. Minus 1, 1 and 0. So 2 minus 1, 1. 0 plus 1, 1 and 1 into A. Okay. Now the next step is to reduce this as 1 and this is 1. On R2 I am taking half of R2 and on R3 I am applying minus 1 by 4 R3. So what do I get? It will be 1, 1, 3, 0, 1, minus 3, 0, 0 and plus of 1. Similar to the matrix 1, 0 and 0. Then it will be minus 1 by 2, 1 by 2, 0, minus 1 by 4, minus 1 by 4, minus 1 by 4 into the matrix A. Now, with the help of this matrix element 1, I need to reduce this element as 0. So I am going to apply on R1, that is R1 minus 3 times R3, and on R2, that is R2 plus 3 times R3. Okay, given operations. So R1 minus of 3 times R3. So 1 minus of 0, that will be 1. 1 minus of 0, that will be 1. 3 minus of 3, that will be 0. Then on R2, R2 plus 3 times R3. So 0 plus 0, that will be 0. 1 plus 0, 1. Minus 3 plus 3, 0. So 0, 0 and 1. Then what we are having on the other side, we have 1, that is our R1, minus 3 times R3. R3 is minus 1 by 4. So minus of 3 minus 1 by 4. So it will be 1 plus 3 by 4. So it will be 7 by 4. Next 0 minus 3 times minus 1 by 4. So it will be 3 by 4. And the last one, 0 minus 3 into minus 1 by 4, again 3 by 4. On row second R2, what we are having? Minus 1 by 2, minus 1 by 2, this minus 1 by 2, plus 3 times minus 1 by 4. So it will be minus 1 by 2 minus of 3 by 4. I will take 4 as LCM. Minus 2 and minus 3, minus 5 by 4. Next is 1 by 2 plus 3 times minus 1 by 4. So 1 by 2 minus of 3 by 4. So 4 LCM, 2 minus of 3, that will be minus 1 by 4. Then 0 minus 3, so it will be minus 3 by 4. Then minus 1 by 4, minus 1 by 4, minus 1 by 4 into the matrix A. Now next step is I need to reduce this one as 0. So on R1 I will apply R1 minus of R2. So I got now 1 minus of 0, 1, 1 minus 1, 0, this will be 0, 0, 1, 0, 0, 0 and 1. Similar to now 7 by 4 minus of minus 5 by 4. So 7 plus 5, 12 by 4, that will be what? 3. Next is 3 by 4 plus 1 by 4. 3 plus 1, 4 by 4, 1. Next 3 by 4 minus plus 3 by 4. So it will be 6 by 4, that is 3 by 2. Rest of the elements will remain same as it is. minus 3 by 4, minus 1 by 4, minus 1 by 4, minus 1 by 4 into A. So now just check, do we get the identity matrix from this one? Yes, we get. So identity matrix reduces to I is equal to B into A. Now what is this B? This B is our A inverse. Okay. Why so? Because we have an identity, just a minute, 8 by 4, minus 1 by 4, minus 3 by 4, this one, minus 1 by 4, minus 1 by 4. Its order will be the same, 3 by 3. Now why we are telling it is A inverse? Because we have studied a property, A inverse into A is always equal to I. So this matrix B will be taken as A inverse, because A inverse into A is equal to I. Hence, which is the required result? Which is the required inverse, A inverse. Okay. Now let us take one more question from the same concept. So now we have a matrix, find A inverse using Gauss Jordan method, where we have given A matrix that is equal to 1 3 3 1 4 3, then 1 3 and 4. Again we have a 3 by 3 matrix. So solution will be, let A is equal to identity into A. Now the value of A is 1 3 3 1 4 3 1 3 4 is equal to 1 0 0 0 1 0 0 0 and 1 into A. Okay, I need to convert this matrix A into identity matrix. So first operation will be on R2, that is R2 minus of R1, and on R3, that is R3 minus of R1. So first operation will be 1 3 3, R2 minus R1, 1 minus 1 0, 4 minus of 3 1, 3 minus of 3 0, 1 minus 1 0, 3 minus 3 0, 4 minus 3 1. Similar to now first row will remain as it is, because we are not operating any operation on R1. R2 minus of R1, that is 0 minus 1 minus 1 1 0, R3 minus of R1, so minus 1 0 1 into the A matrix. Now next step is to reduce these two elements as 0. So first operation will be on R1, R1 minus 3 times R2. Okay. Yes, now we have to apply on row R1, that is R1 minus 3 times R2. So it will be 1 minus of 0, that will be 1, 3 minus of 3 0, then it will be 3 minus of 0, that will be 3. So 0 1 0 0 0 and 1 is similar to the matrix. Now 1 minus of 1 times 3 times minus 1, so it will be 1 plus of 3, that will be 4. Then we have 0 minus of 3 minus 3, then 0, then minus 1 1 and 0, minus 1 0 and 1 into the matrix A. Next I need to reduce this 3 as 0. Okay, so the operation will be on row 1, that is R1 minus 3 times this element R3. So it will be 1 minus of 0 1, 0 minus 0 0, 3 minus 3 0. Second row and third row will remain as it is, similar to 1. So 4 minus 3 times R3 minus 1, so 4 plus 3 7, then minus 3 minus of 0, so it will be minus 3, 0 minus of 3, minus 3. Then the second row will remain as it is. Now need to check whether we have converted the given matrix A into identity or not. Yes, all the elements over here are 1 diagonal elements, the rest of are 0. So it will be I matrix similar to B into A. Now where this B is equal to A inverse. 7 minus 3 minus 3 minus 1 1 0 minus 1 0 and 1, which is the required inverse of a matrix. Okay, I think so concept is clear to everyone. Now our next lecture will be on the rank of a matrix, so we will be discussing in the next lecture. Thank you.